Hello, in this video we'll talk about the Gaussian elimination method with systems of equations with three equations and three unknowns. And when we do these type of problems, the first thing we want to do is convert the system to a 3 by 4 augmented matrix. Then we want to simplify the matrix to an upper triangular matrix with zeros below the diagonals. And then convert the matrix back to a system of equations and perform back substitution to get the final solution. So let's look at a problem. So basically what we want to do is write 2x plus y plus z is equal to -2. And then we have 2x minus y plus 3z is equal to 6. Then we have 3x minus 5y plus 4z is equal to 7. So we want to write this as a 3 by 4 augmented matrix. So this will be 2, 1, 1, -2. Then this is 2, -1, 3, 6. And this will become 3, -5, 4, and 7. This is our 3 by 4 augmented matrix. So now we will perform row operations. Now remember from what I mentioned in the last video is that you may have some values. Let's just pretend basically show what an upper triangular matrix look like. So if you have something like 1, 1/2, 1/2, and say -1, and say 0, 1, 1, and this is going to be 0, 0, 1, and say this might be 4. Hang on, let me put this here and this here. Okay. Just basically showing you what this thing here looks like. See? So you have these things called row leading ones here, which are, we consider pivot points. And all the zeros are below the diagonal. This suggests that this type of problem is in row echelon form. Row echelon form. So that's the goal, to get this problem in this type of form, and then we will switch this problem back to systems of equation and actually solve and get the final solutions that way. So basically now, after we have shown this matrix, we want to basically get a 1 in the first position. So as we recall, this was the matrix. And basically here, It's always a nice pattern to go, and I'll discuss the patterns that you should do when we talk about Gauss-Jordan method. Okay, but here we want to get a 1 here in this position, a 0 here, a 0 here, and a 0 here, right? So we want to divide row 1 by 2 to get the new row 1. And so when we do that, showing my work, we find that we get 1, 1/2, 1/2, -2/2 would be -1. So that's what we get, that's our new row 1. So our new row 1 is going to be 1, 1/2, 1/2, -1, okay, and the rest of the rows will stay the same for now. So this is what we have. And the next thing we do to get a 0 here in this position, want to get a 0 in this position. So we will take -2 to row 1, add it to row 2 to get the new row 2. So when we do that, that's going to be -2 times row 1, and then this will be -2, -1, -1, and 2, and then we add it to row 2 like so. And then this becomes 0, -2, 2, and 8. So now we have this matrix, which is going to be 1, 1/2, 1/2, -1. This is 0, -2, 2, 8, and then the third row remains the same, and this is what we have. Now, the next thing we want to do is get a 0 in this position. So we want to multiply -3 we want to multiply -3 to row 1, add it to row 3 to get the new row 3. So this will be -3 times row 1, and then this will be -3, this will be -3/2, this will be -3/2, this is negative times a negative is positive, so it should be +3, +3, and then we add it to row 3, And when we add this to row 3, this is what we get. 0, negative 13 over 2, 5 over 2, and then this will be 10. I see that. Okay. So setting up this matrix, this is what the matrix will look like. New matrix after doing those calculations. 1, 1 half, 1 half, negative 1, 0, negative 2, 2, 8, this will be 0, negative 13 over 2, 5 over 2, and then 10. Okay, so look at what we have so far. So the next thing we would like to do is we want to divide row 2 by negative 2. So where I'm going here in my next task is going to change this. So we went from here to here to here. See the pattern? And now we could have went this way, but rather than better, we'll go straight to the middle to change this negative 2 in this position to a 1. So we want to take row 2 and divide it by negative 2 to get the new row 2. So when we do this, this will be 0 over negative 2, negative 2 over 2, negative 2, negative 2 over 2. And then this is going to be 2 over negative 2. Okay. And this will be 8 over negative 2. So now what we have here is going to be 0, 1, negative 1, and then here we have negative 4. So take a second, pause the video, and copy this down. So this is 1, 1 half, 1 half, negative 1, 0, 1, negative 1, and negative 4. And then we have 0, negative 13 over 2, and this is going to be 5 over 2, and then this is 10. So now what we would like to do is get a 0 in this position here, in this position. So we're going to add, or should I say multiply, 13 over 2 to row 2 to get the new row 2. So let me write that out. So this will be what we're doing is taking row 13. Okay, my pen is acting up. So we say 13 over, well, let me write out the algorithm. Yeah, 13 over 2 times row 2 added to row 3 to get the new row 3. That's what we're trying to do. So when we do this, distributing 0, 13 over 2, okay, negative 13 over 2, okay, and then this will be and that is absolutely correct. Just wanted to make sure. Okay, so next we're going to add this. Since we multiply 13 over 2 to row 2, we're going to add it to row 3. So here, row 3 is going to be 0, negative 13 over 2. This will be 5 over 2, and this will be 10. So this becomes 0, 0, 8 over 4, which is going to be negative 4, and then this is going to be 16, negative 16. There we are. Now, now that we have this, that's our new row 3. So our matrix, our new matrix basically will look like this. 1, 1 over 2, 1 over 2, negative 1, 0, 1, negative 1, negative 4. This will be 0, 0, negative 4, negative what? 16. Here we go. So basically this is in row echelon 4, but you know I like to have all my row leading ones on the diagonal, right? So it makes it easier to do final calculations that way. And what we have, we're going to take row 3 and divide it by negative 4 to get the new row 3. Everybody see that? Take a second to copy that. So our row 3, let's write that out again. So 1, 1/2, 1, negative 1, okay, 0, negative 1, whoops, not negative 1 there. Should be a 1. Negative 1 here. Negative 4. 0. 0. This was negative 4 and negative 16. So we said that we would divide row 3 by negative 4 to get the new row 3. So that's going to be 0 over negative 4, 0 over 0 over negative 4, negative 4 over negative 4, and then negative 16 over negative 4. So this will be 0, 0, 1, and this is going to be positive 4. We see that. So our new thing, our new matrix in row echelon form So what's the last thing we're going to do? Last thing we're going to do in this particular situation, now that this is in row echelon form, is we're going to write this as the systems of equation. This is going to be 1 or y minus z is equal to negative 4. And then z here is equal to 4. So what we do here is we put this back into the equation. We substitute the z back into this equation. And so we see that y minus 4 is equal to negative 4. So we're going to solve for y. And in this case, y is going to equal to 0. So we see that y is equal to 0. And now z is going to equal to, well, we always found that z is equal to 4. Okay, take a second to copy that. Really can't leave off this here. There we are. So as you see, we have to be very careful when we do these calculations and not rush through the problems, because if you get one sign incorrect or one value incorrect, the whole problem is wrong. And it was a lot of work done in vain. So you want to make sure that everything is appropriately calculated. So be responsible, be very, very careful with your algebra and arithmetic, and try not to be too careless. So this is what we have. So now we will clear the screen and continue. Make sure that everybody has this copy. You can always pause. So now we're going to substitute the values back into the first equation. The first equation, let's write down the first equation that we had. X plus 1/2 y plus 1/2 z is equal to negative 1. And so we have Now x. Now this is back substitution here. We're plugging back in those values for y. Let's put down, let's put down what x is going to equal to. We know that y is 0, and we know that z is 4. So we're going to plug these back into the original first equation. So this is going to be 4, 1. So we do that, perform back substitution so we can solve for x. So x plus 2 is equal to -1. So we have -2 to both sides. And here we have x is equal to -3. X is equal to -3. Okay, so with this problem, our final answer is x is, as you see, x is equal to -3, y is equal to 0, and z is equal to 4. And as a written as coordinates, as a coordinate on 3D, will look like this. So remember, you can always go back and check your answers by plugging these values into the equation, right? The original equation. And let's do that. Let's run a check to make sure that everything came out okay. So let's run a check. It's always good to check your work. So we had x is equal, let's run the check. Let's write check here. Check the solutions. So here we have we had x is equal to, what was x? X was equal to -3. Y was equal to 0. And z was equal to 4. So this was our original problem here. Well, let's just write down and plug these values in for x. Okay, plug everything in where y belongs. And then c, whoops. That's going to be z is 4. We're going to see what that equals. Now, second equation was 2 times -3 minus 0 plus 3 times 4 and this was going to be 3 times -3 minus 5 times 0 plus 4 times 4. So let's see if this comes out right. So here this is -6 plus 0 plus 4. And our original answer for that was 2. So it was 2. So 2, and it was -2. Let me make that better. Let me make that neater. It was -2. So we're getting the original stuff from before. Okay. Now this is going to be negative 6 minus 0 plus 12. So what we get, negative 6, this is going to be negative 6, will be negative 6 plus 12. So you're going to get an answer here, result here of just 6. Okay, so we're correct so far. And remember, when you get the solutions, you want to always, when you check your solution, just don't check them in one equation. Check them on all three of the original equations, or all, two of the original equations, or whatever, how many equations it was. Check your solutions in every single last one, because sometimes it works for one, but don't always work for the others. Okay, so remember that. So that happens sometimes, believe it or not. Okay, and this is going to be negative 9 plus 16, which is going to give you an answer here of what? Gives you an answer here of 7. So we were correct. So our original problem was this: 2x plus y plus z is equal to negative 2, and 2x minus y plus 3z is equal to 6, and we had 3x minus 5y plus 4z is equal to 7. So we see that. So we got our original numbers when we actually found these solutions to the problem, the solutions to the actual system that we solved, right? So we're correct. So this concludes our example of the Gaussian elimination for a systems of equation with 3 equations, 3 unknowns, converted to a 3 by 4 augmented matrix.